So great, I'll get started. So my name is Jonathan Reinhardt. I'm a technical consultant on behalf of Autodesk resellers across the UK and Ireland. And today I'm going to present moving to the AEC Collection if you're currently using Revit, and I'll cover that in a couple of slides moving forward. So a little bit about myself. I'm a technical consultant, as I said. I've about 13 years in the AEC industry, so I've worked as a BIM manager and an architectural technologist, primarily in architecture, but I've also worked in engineering as well. I've also studied a master's in BIM management and a degree in architectural technology, and I speak at various events as well, including the London BIM Summit at the recent Construction Week as well last year. So that's a little bit about me. So what are we here to talk about today? So I just want to lay down some context of, I suppose, moving from Revit to an AEC collection. What does that actually mean? And in the terms of BIM, what does that mean as well? So it means that you have more connected workflows, you have more connected design processes, and you're more connected to your finished building as well, or your finished product, whether it's engineering or construction or architecture. That's all more connected, and you're able to retrieve information that you've created in the design process, and this information can then be used to provide to facilities management and building operators as well. So it creates a more connected environment within the BIM workflow as well, right through to the end. So I suppose this is the McLeamy curve. I don't know if some people have seen this. It's produced by the American Institute of Architects as well, but it's quite widely used in BIM adoption globally. So it just shows that as the cost of a project goes on, and we all know this from an early stage, to make changes later on in the process. So once you get from your pre-design stage and working right your way up to through to operation stage, if you want to make a change to a design, it's quite costly. That goes without saying. So if it's changing a drawing or a 3D model at an early design stage, you know, a slight cost impact, some labor required there in terms of an architect or a designer making changes to a drawings. But once the project moves along, as you can imagine, when it becomes more real, like the construction guys are on site, it's actually being built, foundations have been poured, and walls have been constructed, it becomes more expensive to make changes there as well. So just being conscious of that, and hopefully what I'll communicate today is that within the design process, we're able to reduce some of these cost impact, and with better workflows through different software. So what we hope to do is have this ability to impact the cost, and this shows across a project that it's harder to impact the cost of a project as a project moves along as well. So you have less ability to do that as it becomes from design stage right up to through to completion and operation stage of a building. So just some benefits that we've seen from the McGraw-Hill construction report. By using digital processes and using BIM processes, some of the benefits we've seen is over 70% of people have said that there's a greater cost predictability. We've got a higher improved schedule. We've got a lot less errors on site and in the design process, and we're able to optimize our design as well because of the use of digital tools. And it also presents a better understanding of the design and of the building and of the finished project as well. So just some documents I'd like to highlight as well. This was released recently at the end of May 2018, and this is from the RIBA, and Microsoft produced this, and this is about digital transformation within architecture. And just to take this as a snapshot of that, Microsoft, a fairly large, if not one of the largest technology companies in the world, you know, have produced this report, and this shows that their awareness of BIM and their awareness of digital technologies within the architecture and across AEC industry is becoming more prevalent. So they're aware of all these things happening, and it's quite an interesting report, I have to say, and to see where the industry is heading as well, to be able to look at the impact of technology as we move through a digital age. So looking at the likes of IoT, artificial intelligence, and then various other tools like augmented reality, virtual reality, and cloud computing as well are all analysed and where we're heading within the industry, and that's definitely well worth the read. And some other documents I've seen come out of the UK, this one's quite good, the Bryden Wood and University of Cambridge, is how they bridge the gap between construction and manufacturing, and looking at the prefabrication market and where that is heading and what we need to do to get our buildings to that stage as well. There's also the Farmer Review of the UK construction labour model, and we see inefficiencies throughout the construction industry, almost quite similar to the agricultural industry, a fairly manual industry already, but looking at that in the context of the construction industry, and how we have quite low efficiencies in certain parts of the industry, and the reasons to digitize as well. And then also the RIBA report for the future of architects as well is also well worth a read. And we see that by 2050, 70% of people will be living in urban areas. So we need to get smart cities, and we need to improve our built environment to accommodate and to support such large cities and dense cities with better infrastructure and better buildings as well. So I'm sure we've all seen this slide or this analogy. We've seen moved from drawing board into CAD. And today, what I hope to communicate is that we're going on this change again, not just from drawing board to CAD and CAD to BIM, but also from within BIM itself. When we look at the workflows between different software, between different disciplines, and when we talk about collaboration and digital collaboration, that's a massive change and shift that is happening within the industry as well, and within BIM itself. So if we look at the 3 years of technological disruption, we had the PC and CAD emerging, we had BIM, and now we're in the era of connection, and we've got connected BIM, and we've got intelligent information and intelligent objects and intelligent buildings and smart cities that we want to connect to as well. And we're able to use all of this design information that has been created within a collaborative and digital collaboration processes as well, in a lot more efficient method. So what I'm going to cover here is the AEC Collection, which is a suite of products from Autodesk, and this includes all of these products, and I'll go through the full list and go through a lot of the workflows within there as well, but just to show you the value that you get from an AEC Collection. Usually with the cost of an AEC Collection, if you're buying 2 products or more, an AEC Collection is actually less cost straight off as well, so an immediate cash saving there as well if you're using more than 2 products within your office. So for example, if you're using Navisworks and Revit, or if you're using just Revit and AutoCAD, it's better value for money to have the AEC Collection, and you can check for quotes or costs with your Autodesk reseller. But just to see all the products you get within that, and people are usually quite surprised that you get so many products for the low cost that it is, but it's quite a beneficial suite to have because of the workflows between particular products, and I'll run through some of them next as well. So just looking at the suite of products, we've got your standard Revit within there, but we've also a lot more. So we've the likes of Revit Live for VR, InfraWorks for infrastructure modeling and fly-throughs. We've got Navisworks Manage for construction, clash detection, quantification, 4D simulation. We've also got Forma Pro, which I'll run through in the next few slides. We've got Insight, which allows you to do building analysis, Recap Pro for taking in laser and point clouds, 3D Max Interactive, which allows you to enhance your 3D or your BIM models into interactive and walkthrough, very high quality rendered videos and interactive virtual reality walkthroughs as well. I'll go through some of those workflows. We've also got Dynamo Studio, which is visual programming for non-programming. For non-programmers, this allows you to automate a lot of work within Revit particularly, and being able to rename sheets. If you have hundreds of sheets to rename, you can use something like Dynamo, but that's one of the basic examples, but I will go through some fairly practical examples as well. You also have access to A360 rendering, which is rendering from within the cloud, and that's from within Revit sending your model up to the cloud and rendering an image within usually less than 10 minutes of fairly high quality. That does require cloud credits, but you do get 100 free cloud credits with an AEC Collection. There's also 25 gigabytes of cloud storage as well. We also have structural analysis for Revit, structural bridge design, Robot Structural Analysis Pro for the structural engineering side of things, advanced steel as well, which is becoming a lot more prominent in the structural and civil area as well. And we also have the one AutoCAD. So AutoCAD is now packaged under one complete solution, and this includes AutoCAD Architecture, Electrical, Map, MEP, Plant 3D, and AutoCAD Raster Design as well. And we have FabCAD MEP, also Civil 3D, and some vehicle tracking software as well. So that's everything that's within the AEC Collection. You don't necessarily have to be using more than 3 or 2 of those products to be getting value for money, but just to see what's capable there within the AEC Collection. So looking at the benefits of Revit, just to give it some context, and this as our main primary BIM authoring tool, we can pull 2D and 3D models from Revit. It's coordinated information between your drawings and your 3D model are all linked, and when one change occurs, it happens within your drawing or within your 3D model as well. And you have full access to architecture, structural, mechanical, and electrical modeling tools as well within the full version of Revit. And this is included in the AEC Collection also. And it also enables more connected workflows as well. And that's what I will show today within the AEC Collection. So starting off at design stage of a building, looking at this tool, Format Pro, and I'm going to demonstrate how this works now as well. So this allows you to create conceptual massing, perform energy studies, and to do design reviews through collaboration as well. And you're then able to push that information directly into Revit as well. So I'm just going to draw a quick line here just to show you it's a fairly intuitive user interface, and it's fairly basic and fairly easy to use, but you can go quite detailed on it. So I'm just going to locate my site just so I can pull in the weather and solar information. So I'm going to locate it in my local city here in Cork in Ireland. I'm just going to import that satellite image. So it pulls all that imagery in from Google Maps, and you can see you can set your site context now. Simple, that's done in a matter of a minute. Now I'm just going to draw a simple volume on the site to represent a building. Just going to draw a footprint of where I think a building might go. And you can look at this as an early design or feasibility stage. A client has approached you, or you might want to show somebody what a building might look like on a site. You can then extract that volume up to whatever preferred height you want. You can change that height just by clicking on it as well. You can also apply levels to that. Just going to perform a quick shadow analysis on this as well, just to show you what you can get out of a few minutes work. So because this site has been geolocated, the solar analysis is fairly accurate within this as well, and it pulls information, geo information and GIS information from the local area as well, so it knows exactly where the site is. So it's a fairly accurate demonstration of what a shadow analysis might look like if the building was actually constructed. So I'm going to look at solar analysis as well, and this is going to look at the solar radiation impact on the building facade. Now this can help you inform your glazing ratios if you need sun shading devices or brise-soleil on a certain aspect of your building. And once you hover over each facade, you can see that's the south facing facade has 727 kilowatt per hour over a year cumulative, and you can see the north side facade has a lot less, and it's color coded to quite a blue kind of colder color there. So you might know on your south facing facade you need to put in less glazing, or you need to put in some sort of shading as well. I'm also going to apply some levels to this as well. So I'm going to apply 10 levels. Just going to select my volume, just going to use levels, and I'm just going to pull down my building to suit that as well. Let's move that away there. Just click on the top face, and then pull it the opposite way from extrusion, pull it down. I'm just going to set that, and I'll show you the relevance of creating the levels as well. Now I'm going to export this into Revit, so I'm going to show you that you can reuse this geometry that's already been created. It's not in a separate 3D file, not a separate 3D program. It is a standalone program, but it does link directly into Revit. So I'm just going to export that as an AXM file. I'm then going to open up Revit, close that. Just going to open up a new template, just a blank template, show you how that imports. So add-ins, when your format tab there, you can see import format to Revit, and that brings in your geometry. So it brings it in as a massing geometry. So make sure that your mass is on within visibility graphics, which is turned off by default, usually within Revit. And that's what's happened here. So you can see it's brought in the 10 levels that I created within format. So it means you don't have to recreate them. You create them once in format and they're automatically brought in. And it's also located the site to the location as well within the location settings. I'll show you that in a moment. So I'm just going to turn on my massing here. So you can see it's brought in the geometry from the site that I've created, all the levels. So I'm just going to convert these walls by face. I'm going to select the wall type by face. So I'm going to go for a curtain glazing, say this is a commercial office building, for example. Just going to click on that, it's place that glazing. Again, on the end facade, main facade. And then just on the south facing facade, I'm just going to make that all brick cavity construction or precast construction or in situ concrete. This is an example. And then I'm just going to hide the geometry that was imported. So I'm not deleting it, it's still leaving it there as a reference. So I've just hidden it. So you can see I've created the intelligent objects already. You've got your wall content, your wall buildup, and you've got a basic floor plan created there already. I'm going to hide that geometry. But I've no floors. So how do I go about creating floors? So it's quite a similar process. Because of the levels that have been created already within format, I'm able to create a floor by face. I can just select each level that's already been created. It's just a blank mass. Just going to create each floor. Just click create floors, put on my shaded. And you can see if I cut a section through that, you've got a basic building created already, just within less than 5 minutes of creating a massing volume within format, and all that information can be imported and reused then within Revit. So you can see you've got basic information there, but it can be as detailed as you make your floor buildups or your wall buildups as well. And this could be a design model that's been iterated within format over a longer period of time. You've only focused on creating the format model, perhaps for presentations and client design presentations. And you can see it's brought in the coordinates from within where I created that within format and geolocated it as well. You can see it's automatically brought in that information already. So that's Format Pro. So next, what I'm going to show you here, I'm going to show you the link between Revit and AutoCAD and another workflow within the AEC collection. So I'm just going to show you how these can work together. So this is a video. So as we all know, within Revit, you can place a wall, and you can see in the 3D view in the bottom left corner, it's going to place that 3D wall there. But what if we want to work with external consultants that are using AutoCAD or don't use Revit and want access to our DWG or our CAD files? How do we get that information to them? So this is just a collaboration workflow to allow you to work in Revit, but to collaborate with external consultants or if it's people internally as well, but especially with external consultants that mightn't have moved to BIM or may not be in the BIM space at all. You have to export that to a DWG. It exports all the layering and smart information. So you can create custom layers as well, or the already default layers that it creates. And then you can see within Revit, you can import that just open it as a DWG. And I'll just go back in that you're able to snap to all this information as well. So it's all intelligent CAD information also, and that this is all being created within Revit. But again, you're able to use it within another platform as well. And then moving on, looking at the more detailed design process, looking at virtual reality after you've created some initial design drawings, you want to be able to visualize your building or visualize your design, either from an architecture, engineering, or even from a contractor's point of view as well. Wants to see what the construction might look like. And you can see we have even a scaffolding model here on this middle image here. But with Revit Live, we're able to upload our model within Revit straight up to the cloud. Within a matter of minutes, it will send it back down, and we can plug in our HTC or Oculus Rift or various VR headsets, plug that into our VR machine or our workstation, and we're able to walk through the building. So I'm just going to show you an example of that workflow as well. So I'm just going to select some views here. So these are just 3D views that have already been set up within Revit. And by setting up these 3D views, so the model is obviously already been created, the information's been put in, you're just placing cameras to create these views. Those 3D views can then be exported as viewing points for your interactive 3D model. So you can jump to those viewpoints within your VR model as well. I'll show you this now. And this can be all done within a VR headset or just on a desktop by navigating using the keyboard or clicking with your mouse as well. So you can see it uploads to the cloud there directly from within Revit. Once it's been processed within the cloud, you then open that within your Revit Live model, with Revit Live model viewer. And again, this is all part of the AEC Collection. It's just an additional workflow. And Revit Live is not available on its own. It's only available as part of the AEC Collection. It originally wasn't in the AEC Collection, but is, I think, since last September. So really broadens your access to being able to provide virtual reality to clients, either as an additional service or just to show them how their design might look. So just to open this up within the Revit Live viewer. So as I said, this can be viewed on a desktop. You can do different plane views, but I quite like the realistic views. And it pulls in all your materials that you've created within Revit already. And just by clicking, you're able to pull yourself through the building, and it will automatically walk to locations. And then you can see in the bottom right, if you click on VR, it will automatically, if you have a VR headset plugged in, it will automatically show up on your virtual reality headset as well. So the pins are the 3D views that I showed being set up within Revit, and it just means you can jump to these viewpoints on your right-hand side tab here. So look at the pool table, and you can see the lights. If you have lights set up in Revit, it automatically turns on the lights, and it's accurate light readings from the lux count that you have attached to your electrical families. So if you turn the daylighting down or the sunlight down outside, the lights will automatically get brighter as well. And just to run through to see, you can see it at different times of the day, and you can see the light reflection on the different materials as well. So that's just Revit directly to Revit Live. Also publish it to Windows as an exe file or to an iPad as well to be able to interact on a mobile device. So I'm going to look at looking at taking your Revit Live model or looking at adding a bit more detail to it. If you want, you can still use it just as a Revit Live viewer, but if you want to add more detail, add more realistic information to it, material information to it, there's also a process for doing that as well. So looking at moving from Revit and looking at pushing your model into 3D Max, pushing it into 3D Max Interactive also, which are our workflows for, and you're able to then access this information on all of these mobile and virtual reality devices as well, and on your desktop computer. There's also some Maya workflows there if you wanted to take that route as well. And I'll just show you how the final model works as well. And as you can see, the top Revit Live workflow still gives you quite an output, but it's quite a simpler process. And if you want to go that step further, you can go the 3D Max Interactive route, and I'm going to show you an example now. So this is a video enhanced using 3D Max Interactive, and I hope this comes across on your screens. But if you look at the lighting on the floor and the bounce off the light and the camera work within this, you're able to, and the reflection on glass, this is all enhanced by baking lights, adding in additional materials, all done through 3D Max Interactive, taken straight from Revit. So adding in and creating custom materials. You might have a library of materials you can use across a number of projects, but you're able to then run this process again. You're able to add in the better detail and make it far more presentable, very, very high-end presentation and detailing you can see out of this, even the glow off the lighting as well. And you can walk through this as well using your keyboard arrows, and you can create interactive points as well. You might be able to click on an object, and you can, if you click on the table, you can change the table object as well. And just, I think that it's quite realistic there when you compare it to Revit Live as well. So all available within the AEC collection. So that was 3D Max Interactive. So looking at moving your design along from your design stage, looking at moving into a lot more detailed design stage, and looking at some building analysis and building lighting analysis in particular. So we use Autodesk Insight for that. And this again is a plugin included within Revit in the AEC collection. And it's just a matter of, within your Analyze toolbar, sending your model up to the cloud, performing a lighting analysis. You can see here, I'm just going to pause this video. You can see here it's created a floor plan of showing you the daylight impact on your floor plan. So the red areas, obviously you might need to install some artificial lighting. There must be walls, or for whatever reason there's no daylight getting in there. And you can see the yellow areas, obviously you're getting a lot more daylight in those areas. What it also does, it creates a schedule. You can base this on the LEED standard, which is built into the schedule as well, and it will give you a lux counting for this as well. So it tells you the different threshold for the LEED standard, but you can also create a more basic standard, but it will give you the lux and the foot candles rating for each of those areas as well. And you can also view it in 3D as well. You can see this is a 3D cup floor plan that shows you exactly what that floor plan is going to look. And this can inform, these are your foot candle counts as well. And this can inform where your lighting or your artificial lighting needs to be installed, or where you might need to accommodate further elements of glazing as well. So that's Autodesk Insight. So moving on from that, looking at AutoCAD Civil 3D as well, looking at the more civil engineering side of things. This is also included in the AEC collection. So you're able to do civil design, you can perform iterations and streamline more time-consuming tasks. And again, you're able to produce drafting and documentation and perform visualization and analysis as well. And you're also able to collaborate further as well and overcome your team coordination and workflow issues as well. So that's AutoCAD Civil 3D, and it's used quite widely in the civil engineering industry as well. So I'm just going to show you some clips of InfraWorks. InfraWorks again is a civil tool. It's a bit more basic than Civil 3D, but it's meant for early design and concept analysis. So I'm going to show you a road creation and roundabout creation within this. So what InfraWorks has, it has a built-in library of roads and roundabouts and different road types, and you're also able to link in Revit information into this model as well and create 3D fly-throughs. So I'm just going to go back to that. So that's a design created within Civil 3D. It's then pushed into InfraWorks, and we're just going to add some more 3D information to this. So we can change the design of that. You can see all the road junctions increase with it. We move, everything moves with it. So they're intelligent objects. So now we can view it in 3D. We can flex with the direction and the curve of the roundabout as well. And then we're able to export this information as well to reuse it. So just going to select an area around the roundabout. Then within Civil 3D, you can then import all of that already created information. And can see it's imported as CAD detail, as intelligent drawing lines are able to snap to all that information as well. So you've created once within InfraWorks at your early design stage, and then you import it for your detailed design stage as well. And there's a whole range of and library of various civil objects and road layouts within there as well. So that's Civil 3D. So looking again at a workflow within InfraWorks, and this is one I created myself. So this is looking at taking some InfraWorks context information of a city and bringing it into Revit as well through Navisworks. Here we are. So this is InfraWorks again. I'm going to go to the model builder. I'm going to locate my site, choose Dublin City. So I'm just going to pick this site. So it uses Bing maps within this interface. Just going to locate my site with my address. I'm going to name it accordingly. You can then send that up to the cloud, save it within your project files, within BIM360 as well, which I'll touch on later. So I'm going to create that model. So what that does, it takes a matter of minutes. It brings in all the coordinates, all of the intelligent information. It's going to bring in some of the 3D information that is being created using a plugin called OpenStreetView that has a direct link with InfraWorks, and I'll show you the benefits of that now. It's just going to take a moment to import. So you can see it's brought in the 3D information. It saves you having to recreate this within a 3D modeling tool, and you're able to import this as site context. It's the accuracy of it is good for a 3D modeling or creating a 3D view around your site or the context of your site, and you're able to place your building design within that 3D information as well. So you might have a greenfield or brownfield site within this, and you want to place your building model. So I'm just going to show you how you then export that information into Revit. You can also turn off the imagery on the buildings as well if it doesn't suit the 3D look that you're going for. Just want to skip ahead with this. And once your model is ready, you get an email through then as well before you've created your InfraWorks model. Then to get this into Revit, you're able to bring this to Navisworks, import it, say here in my documents, an FBX file, open it, and then what I'm going to do, I'm going to save that as a Navisworks file. You can see it's brought in all the 3D information, even the 2D aerial map as an NWD file, and then I'm going to link that within Revit as well. And you can see within Revit, you can directly link in that information, and you can create your building and place your building within your site there as well. And it's suitable for creating 3D videos, 3D context, and 3D fly-throughs as well. So looking at robot structural analysis, so looking from a structural engineering point of view, this allows you to better manage the integration of structural design analysis, but also to, I suppose, to benefit on interoperability with various other Autodesk structural engineering solutions, and you're able to transfer drawings from design and analysis to fabrication solutions, and you're able to use a solution that supports local conditions, including languages, designs, and codes. And then you're able, excuse me, you're able to perform various load and structural calculations and analysis using that as well. And again, this is available within the AEC collection. And then moving on further, looking at some of the versatility of this product. So being able to create reinforced concrete design, modules, steel design, and timber design as well. And that's all part of robot structural analysis you can perform on all of these types of materials as well, and different types of analysis. So looking at being able to do some localized analysis, you can do country-specific support and reporting. It also has multiple languages and units, and it's got an extensive output of analysis results as well. And then looking at advanced steel, where does that integrate? So if you're looking to push some advanced steel information out to CNC machines, you can actually export it to MIS and to NC files as well. So looking at the prefabrication workflow there from Autodesk Advanced Steel. I'll just show you an example of it here. So it's quite a similar interface to other Autodesk products. You're able to perform certain collision tasks within that as well. And it has all of your steel and structural information attached to each object. You can then isolate those objects, create various joins and various detailing, and pull all of your fabrication, your bill of materials, and your cutting lists from that as well. So that's Autodesk Advanced Steel. And then looking at fabrication within Revit itself. So looking from an MEP point of view, you're able to create all of your ducting, all of your mechanical data, and you're able to push that out using fabrication tools as well. You can apply your different parts, your different bends, your different junctions within your piping and your ducting layout as well. And then this information is used on site as well, and that can go to an NC file, as I said, as well. Looking at capturing existing site information, so using something like Autodesk Recap into Revit 2018. So I'll show you an example here of being able to capture point cloud information. So what Recap actually does, it takes in your point cloud information that you might take from a total station, or a laser scanner or a drone scanner or LiDAR information. You can then break that information up within Recap, bring your 3D point cloud into Revit. So your existing building, for example, you want to refurbish or extend this building, you can then model up that building within Revit, and it also has intelligent lines, so you're able to snap to each of these. In this case, it's creating steps on the entrance of the building, and it rationalizes certain curves as well, down to quite fine accuracy also. And then you're able to place your building design within this as well. So looking at it further, looking at more, I suppose, construction or pre-construction stage. So looking at using something like Navisworks, which performs clash detection, interference checking, and model aggregation as well. So federating your models from different consultants, all different Revit models, you can put them together within Navisworks and perform what we call clash detection. So similar 3D environment, a lot more basic visual graphics, but it's more for the tasks that you can run on this. So being able to perform clash detection. So in this case, I'm going to run a clash detection. So you just click clash detective in your toolbar. I have two models in here, actually three models. So architectural, structural, and mechanical, and these are broken down by level. And again, you can see on the right hand side, architectural, structural, and mechanical. So we want to run a clash test between two of these models as an example. So we're going to pick the mechanical and the structural model, both from, say, external consultants, or it could be internal multidiscipline business. This then shows what clashes. So you can see in the green here, we have a structural beam clashing with some vertical pipes. And that has highlighted this here within the clash detection window, and it brings you automatically to that view, and it will grey out everything else except for those two objects that are clashing, and you're able to visually inspect that as well, and you can check if the design needs to be reviewed. If it's only a small clash, you can change the tolerance of your clash, or something needs to change on site as well. And you can also do construction walkthroughs as well. Fairly basic graphically, but from a contractor's point of view, you're able to use this to perform a 4D construction timeliner as well. You can see this is showing it as constructed across a couple of weeks as well. And as per each day, each floor gets poured, each stairs gets installed, each structural elements get constructed as well. And you can perform that all within Navisworks as well. And it's not just structural models, you can do it with architectural, mechanical models as well. So looking at Dynamo Studio, which I mentioned earlier. So this is visual programming for non-programmers, and this allows you to perform automation and iteration of your design within Revit using Dynamo Studio. So Dynamo was born out of an open source community, and Dynamo itself is completely free as a plugin for Revit, but as part of the AEC Collection, you get a standalone product called Dynamo Studio, and this allows you to create visual scripting. So I'm going to show this example here. So this is a mechanical model and a structural model within Revit, and they're both linked in from Navisworks files, both from different consultants. So I'm just going to open this within Navisworks. We're going to run a clash detection, and we're going to use Dynamo to place clash objects within Revit to identify those clashes for us. So similar to what we've done in Navisworks, just run a clash detection. So I'm just going to run Dynamo, open up the scripting environment. And this pre-programmed script, what it does, it pulls in all of your clash information from your Navisworks file. It then places an object. You can see this arrow, and we can see that the video moves along. It places a clash object, this arrow, within your Revit model. So you immediately know within Revit where all your clashes are, and you're able to schedule all of those clashes then as well within Revit. So pushing that information from Navisworks through Dynamo into Revit and being able to reuse that within schedules as well, and to iterate your design based on that. And this can just allow you then to add more detail to your design if you need to add more builder's oats or be aware of other clashes that are happening within the Revit environment as well. So looking at some other examples of Dynamo, this is using an accessible door example. So within Revit, we place room tags. You can see here, I'm just going to play this example from my colleague Johan within our Belgium office. So you can see here within the properties of that room, in the bottom left is highlighted wheelchair access. So we're going to check that box that room needs to be wheelchair accessible. And then the script, we're just going to show you this script here initially, how you have to run it. So we're going to pull in all of the door information from that entire Revit project. We're then going to connect that door information to get room information. So that's going to find all the wheelchair accessible checkboxes that have been checked within that Revit project. It's then going to turn them out into a list. We're then going to look for them by name, so wheelchair access, whichever ones have been found with that. And you only have to connect these nodes once, and you can rerun this in any project that you have those properties installed on already just by clicking play. So this is just to show you an example of the makeup of how we have nodes, and we have inputs and outputs, and all of this information connects a workflow or a process as well. So we're going to tell it wherever you find a wheelchair accessible checkbox within the Revit properties, we want you to change that door to a wheelchair accessible width. And you can see there, just by running that script once, sorry, let's go back to that. Just by running that script once, it has updated automatically to a wheelchair accessible door. And this is all done using Dynamo as well. So we uncheck the box and the door will change back as well. So it works both ways. So that was the AEC portfolio. I'm just going to touch on BIM360, which is a separate line of products as well, but it does integrate quite closely with products in the AEC collection. So I'm just going to touch on what we call BIM360, which is the Autodesk cloud solution to AEC products as well. So we have design, pre-construction, we've got site products and handover and operation products as well. And these all reside in the cloud. And this example I'm going to show you is BIM360 Design, which focuses on digital collaboration. So this works within Revit. It could be two consultants at different parts of the world, different parts of the country, or within the same office. They want to collaborate. They share their model from within Revit, and you can see here on the swim lane at the top, we've got an architecture, MEP, and structural model, all from external consultants or within multidiscipline practice. And from within Revit, we can sync our models once any changes have been made. Those changes then get sent up to the cloud. It then compares that model to the last model that has been synced, or the last version of that, and it will automatically highlight if any changes have occurred. Very powerful tool here. So we've seen here that there's been 8 elements modified. So these 8 elements of wall here highlighted in yellow, they tell you that that's been from the previous version uploaded to BIM360 Design or synced with the cloud, that has changed. So you're able to compare that as well. It also works within the 2D version, the 2D drawings as well. So automating the checking process of any changes that have occurred within models, as well as the 2D drawings or the drawing sheets that have been uploaded as well. Once those changes have been processed, you can then share that with every consultant involved in the project as well, and they're able to test any changes against those models that have been uploaded as well. And then looking further at BIM360, you're able to access all of that information as well, especially from a contractor's point of view, or even from a designer's point of view, carrying out inspections. You're able to access all of that information using BIM360 on an iPad, mobile devices, and you're able to log information, log checklists, and you're able to log RFIs as well. From a contractor's point of view, this immediately links issues to the 3D model, and you can see here on the left-hand side, you can view clashes and link any RFIs or issues to that as well, and take photographs and attach that as well. So just giving you a little taste of BIM360 and some further workflows beyond the AEC collection as well there. So again, just to recap on all the products included in the AEC collection, there's quite a lot of them. I've ran through as many as I've had time for today, and I'm happy to take any of your questions now. So thank you very much.